welcome today where we're going to investigate parallel and perpendicular slopes. Hopefully you've already done the two Desmos activities. I think they're really great in letting you explore the connections between parallel lines and also the connections between perpendicular lines. So if you haven't done those Desmos activities, go back and play around and discover on your own some of the characteristics of parallel and perpendicular slopes. But after you've played around, you should come up with this conclusion. And that is that for parallel lines, they have slopes that are equal. Because if the slopes are the same, they must be going in the same direction with the same steepness. So if we have a line that has a slope of 1/2, then what we say is a parallel slope. And the symbol for parallel are two long extended lines right next to each other. Please don't confuse them with the number 11. Okay, they're definitely not that. That's why they're drawn a little bit longer and outside the margins of it. So that symbol there means parallel. So if you have a slope of 1/2, a parallel slope must also be 1/2. Okay? And then perpendicular slopes have slopes that we discovered are negative reciprocals. That means that you must take the reciprocal of this fraction and have it going in the opposite direction. So obviously, if one slope is positive, in order to be perpendicular, the other one must be negative, and vice versa. So if we have one slope that's 2/3, then I wonder what the symbol for perpendicular is. Well, the symbol for perpendicular is an upside down T, and it actually looks like two perpendicular lines. So the parallel symbol looks like two parallel lines, and the perpendicular symbol looks like two perpendicular lines. So if we have that slope of 2/3, a negative reciprocal, well, the reciprocal of 2/3 is 3/2, and this is positive, so the negative 3/2 must be the perpendicular slopes. Okay, so there is your two conclusions for coming out of the Desmos activity. Now what we're going to do is use this characteristic to be able to determine whether lines are parallel or perpendicular without graphing. You did mostly graphing in the Desmos activity. We're going to do it without graphing. So this is a very valuable characteristic of linear geometry and linear functions, is being able to determine whether lines are parallel, perpendicular, or neither. So what we have is 4 coordinates. All of these could be on a Cartesian plane, and we could graph them, draw them, and try and measure whether they're parallel or perpendicular and things like that. What we know from our conclusion is the slopes will tell us if lines are parallel or perpendicular. So we're going to find the slope of a whole bunch of different lines and compare them to find out if these lines are parallel and perpendicular. So to do that, we got to use that very, very valuable formula that we learned earlier in this unit, the slope formula. And it's y2 minus y1 over x2 minus x1. Now we're going to be calculating lots of slopes here. So I've labeled this MAB. And since this is a subscript down at the bottom, it's just a labeling device. So this is saying the slope of AB. So the slope of AB, we need to use obviously the A coordinate and the B coordinate. And we will subtract the y's for the rise and subtract the runs for the x's. So here we go. 0 minus 5 then would be the top of this fraction, the y values, 0 minus 5. And the x values would be the bottom, -3 minus 1. Okay, that's subtracting the x values. y2 minus y1 over x2 minus x1. Now let's do these integer mathematics. So 0 minus 5, we're at 0 and we get colder, so we're at -5. And this is -3, which is cold, but we are subtracting cold, so we're subtracting a negative, which is like adding, and we're getting 1 degree warmer, and we're at -2. Now, that is technically the slope, but you see a negative divided by a negative is a positive, so we can reduce this to just 5/2. So that tells us that the slope of the line connecting these two dots, A and B, is 5/2. We don't need to actually graph it to look at that and say rise 5, run 2. We can just use this characteristic to determine if other lines are parallel. So we're asked to compare AB and CD. So CD would be the line connecting these two dots. Where again, you're going to use the same slope formula. But notice I've labeled this one CD. Y2 minus Y1 over X2 minus X1. And just like when we did the slope formula before, I'm going to expect that you write the slope formula down every single time. This will allow you to memorize it. All right, so I've written it down. We're going to do y2 minus y1. So we go to the y coordinate of the second point, which is 3, and we subtract the y coordinate of the first coordinate, which is negative 7. So 3 minus minus 7. And then the x's is the run 4 to 0. We're at 4 and we were at 0, so it's 4 minus 0. So the bottom is okay. 4 minus 0 is 4. 3 minus minus 7 is 10. Remember, that's 3. You're subtracting cold, so you're getting warmer by 7. And you're up to 10. 3. So if you're at 3 now and you started way down at negative 7, you've gone a rise of 10. Now, at first glance, if you look at this 10 over 3 and compare it to this slope, you might say that there isn't really a connection. But all fractions must be reduced. And 10 over 4, there is a number. 2 can go into both 10 and 4. So if you divide the top by 2, you get 5, and divide the bottom by 4, you get 2. Or sorry, 4 divided by 2 gets us 2. And that means that the slope of the line connecting CD is 5/12, or 5 over 2. And that is exactly the same as that slope, which means these two lines must be parallel. And we'll write this symbol, AB is parallel to CD. So you can see how this is such a valuable question. And in fact, this is one of my favorite questions to ask because it asks you to practice all your slope formulas and use the characteristics of them to determine parallel and perpendicular, or neither. All right, so a great activity for you to practice today. Next, we're going to look at the slope between, what are we doing? AB and BC. So AB is right here, okay? And we don't need to recalculate that because we're going to compare it to BC. So we don't need to redo all this. We already know what AB is. It's right there. So we're just going to calculate the slope of BC. So BC are the one that's connecting these 2 points. So again, I'm going to write down my slope formula, y2 minus y1 over x2 minus x1. But now we're doing B and C, C being the second one, B being the first. So if we do the y values, it's negative 7 minus 0. Okay, well, that's going to be easy. And then the x coordinates, 0 minus minus 3. So the top is negative 7 minus 0 is just negative 7, but the bottom is 0 minus minus 3. So you're, again, taking away cold is like adding 3, and you get negative 7 over positive 3. That can't be reduced, so there's our slope. Now let's compare it to AB, because that's what this question asks for. So this slope is negative 7, 3. This slope is 5, 2. Those are not the same, and I don't think they're negative reciprocals of each other. So there is no connection. This is neither parallel nor perpendicular. All right, finally, we're asked to compare AB again. So this saves us some work because it's already done, with a new one, AD. So there's your D value and there's your A value. So finally, we're going to again copy our slope formula down, but this time between A and D. So we'll use the y2, which is 3, minus y1 is 5, 3 minus 5. And the bottom is going to be 4 minus minus 1. So 4 minus minus 1. So the top is 3 minus 2. That gets us down into the negatives. This is 4 minus minus 1 is taking away cold, and we're adding again, so that'll be 5. So I think it is negative 2 over 5. And that can't be reduced, so it's as in the lowest term. Now, let's compare AD to AB. So we're going to compare it to the green one. Here we have negative 2 over 5, and originally the green one we had is 5 over 2. So those are reciprocals. So that's very valuable. And this one is positive and this one is negative. So they are negative reciprocals. reciprocals. And that is, of course, the definition to define that these must be perpendicular. Okay, so this question here is one of my favorite ones. It's one of the things you're going to be practicing in your warm-up. A great way to compare parallel and perpendicular, or not in your warm-up, in your practice. Great way to practice slope formula and compare parallel and perpendicular slopes. All right, the final question we're going to look at is investigating with whether lines are parallel, perpendicular, and neither. But now instead of doing it with points, we're going to do it with equations. So I've got an equation here, y equals 2x minus 3. That's in y equals mx plus b form, so very, very useful. And this one, however, is in standard form. So remember we learned standard form earlier. Not as easy to compare slopes. Why do I want to compare slopes? Well, slopes help me define whether lines are parallel, perpendicular, or neither. We're not using the slope formula here now. We're going to use our knowledge of equations of lines. So this one is y equals mx plus b. So I quickly can tell that the slope here is 2. So that is all the work I need to do. Now I need to compare it to the slope for this guy. Well, this guy is not in y equals mx plus b form. So I have to put it in y equals mx plus b form. So remember, to do that, I need the y by itself, which means I have to do the inverse operation on both the x and the negative 4. So I have to subtract the x and subtract the 4 from this side, which means on the other side I'm going to have a negative x and a negative 4. By doing the inverse operation, it feels like I'm taking that x and moving it to the other side, and the same with the 4, moving it to the other side. And of course, they're going to cancel out here, and if they move to the other side becomes the opposite operation, the inverse operation, and we get negative x minus 4. But that's not quite in y equals mx plus b form. We got to divide both sides by 2, or everything by 2, to get it just in y. So if I divide everything by 2, obviously this is just going to be a y. 4 divided by 2 is going to be a 2. It's going to be a negative 2. And remember, this negative x is like a negative 1x. And so when I divide that, it's going to be negative 1/2 x. And there's my equation in y equals mx plus b form. Now remember, we did this a couple of lessons ago on graspable math. So you'll see there's the same idea. Subtracting the x from both sides makes it feel like I'm going over here and going to the opposite operation. Here the opposite of plus 4 becomes minus 4, dividing both sides by 2, and you get the same equation. This is the imaginary 1 is in front of there, so you see the negative 1/2 x minus 2. All right, why did I do all this? Why did I put it in y equals mx plus b form? Because now I can easily read the slope. And if you look, the slope is the coefficient of the x. So the slope of this guy is negative 1/2. So I've been able to find the slope of the first equation and the second equation, and now I need to compare them. So if I compare these slopes, I've got a 2, which is like a 2 over 1, and the reciprocal of 2 over 1 is 1 over 2. This one's positive, this one's negative. They are negative reciprocals, which means these two lines must be perpendicular. Okay, so you can see why today is such a valuable lesson, because it allows us to practice stuff we had learned in other parts of this unit and use them to be able to determine if lines are parallel, perpendicular, or neither. All right, I've got 2 homework questions I'd like you to practice, and you can just do these on a separate piece of paper, scan them and hand them in. You'll see that they're exactly the same as the 2 questions we just practiced. So there's one here about determining the equations of the lines from finding slopes. So if you wanted to go back and watch this part of the video, you could. And then there's one where you're going to need to rearrange to be able to determine if the lines are equal or not. So here's homework example 1, and you can just pause the video here and recreate this on a piece of paper and calculate the slope of AB and compare it to the slope of BC. Notice that all of them compared to the slope of AB, so you'll just need to do one new slope each time, and then determine if they're parallel or perpendicular or neither. And then compare these 2 lines by, of course, rearranging this and put it in y equals mx plus b. So the 2 questions are right there. You can just copy them on a piece of paper, scan them, and hand them in when you're done. Good luck.